What's happening, dogs? Mr. Allen here, and we are about to graph this dope rational function f of x equals x plus 2 over x squared minus 4. Now, first thing we got to do here, man, is I got to factor if possible. And this is a difference of two squares. I most certainly can factor. I'll still have x plus 2 in my numerator, but in my denominator, I'll have x plus 2 and x minus 2. Now, what is going to happen here? Woo! Woo! We are going to be able to cancel these two bad boys, and I'll be left with 1 over x minus 2. That is my simplified function there. Now, what happens when I cancel? What the heck's going on there? Well, that ends up becoming a removable discontinuity, or a hole, as some will call that. So let's go ahead and jot that down. I'm going to add one more thing to this list here. Holes. We got holes in this one, right? Sometimes they'll do a parenthesis around that because there could be more than one. In this case, it's just one here. I'm going to have that at -2 comma something. Any ideas of how I might figure out that something of where that hole would be located? Well, I have an x coordinate, right? Could I plug that back in to get my y value? I most certainly can. If I plugged it into my simplified one, it's got to be the simplified one, because if I plug it in here, it's going to get 0 over 0. No bueno. All right, so I'll have 1 over -2 minus 2, that's -4. So 1 over -4, or -1 fourth. Boom, there we go. So I've got a hole at that point. Now, I have that x minus 2 that's left in my denominator. What's up with that? Well, that's going to get me my vertical asymptote. So I'm going to have a, vertical asymptote at x equals +2, right? Set that x minus 2 equal to 0, solve. I get x equals 2. That is a vertical asymptote. I'm going to pop that guy on right here. So we got +2 for my vertical. Beautiful. -2, -1/4. That's going to be a whole open circle just like that. All right, man. We're getting some points and some stuff down. What about my horizontal asymptote? Well, let's see here. There's a couple ways to look at it. I have a degree of 1 in my numerator and 2 in my denominator. Small over large means it's y equals 0. I also don't have any kind of a shift going on outside of the function, pushing it up or down, so it will remain at that y equals 0, which is the same as my parent function. So I'll have y equals 0. That's my horizontal asymptote. Okay, so I'm pretty sure the graph is going to exist right here, right? And the other guy is going to end up being over here. If my vertical asymptote was associated with a multiplicity of 2, like x minus 2 squared, then they could both go up or down on the same side. But if it's not, they're going to be alternate spots. Okay, anything else I can get here? How about a y-intercept? Well, y-intercept is always very wonderful, right? And it's the same way to get it no matter the function. If it has a y-intercept, we plug in 0 for x. So if I plugged in 0 for x, so why don't I add I'm going to add a little y-intercept action right here, you know? So 0 goes in for x. Plug it in, whether it's the original or this guy here. I have to go to the original because if there's a lot of factors going on, then it's more math to do, right? So if I plugged in 0 here, that's gone. Here it's gone. 2 over -4 is -1/2. -1/2, which is also pretty easy to see here. 1 over -2, -1/2. Doesn't always work out that way with the factored form if things don't cancel. So 0, -1/2. Go ahead and plot that point there. And I'm going to have a graph looking something dope like that. Jump over the hole there. Boom. Beautiful. All right, now my other part is going to be right over here. Whee! And if I like, I could have plugged in a point, like let's see here, 1, 2. If I plugged in 3, I'd have 1 over 1. So really, I probably would have had a point, you know, kind of more like, there we go. Okay, cool. I don't have to do that. If it asks to plug in a point, you can do that. It didn't ask here. Usually we'll just hole, any intercepts, and then pop the graph in where it needs to go. All right, cool. So anything else? Domain and range, how about? I should answer all the questions, yes. So domain, my domain's all my x values, right? But what do I need to avoid? We've dealt with asymptotes before, so definitely not going to equal 2, but I also have to include that guy right there, that removable discontinuity. So x cannot equal -2 as well as +2. Generally speaking, domain, denominator, not generally speaking, always speaking, domain, denominator. Look at my denominator. Those two bad boys better be a part of my domain. The x values for asymptote as well as holes are always going to be a part of my domain restrictions. How about range? Well, range is a little different, man. Definitely got to remove that y equals 0, right? So y is not going to equal 0, but there's another one as well. My y coordinate, oops, there it is, from the removable discontinuity, which is the hole, which is -1/4. I also cannot equal -1/4. So I'm going to have y does not equal negative 1/4 and 0 as well. Boom. Got our domain. We got our range. That's dope. I like it, man. That's pretty awesome. It's pretty dope and awesome. We could also ask for end behavior. Should we just do end behavior just because it's fun? Let's do it. I got a blank spot right here waiting for some math. So end behavior. And behavior. We'd have as x approaches negative infinity. What's f of x approaching? Well, this graph, as I go further and further to the left, it's approaching that horizontal asymptote. So f of x goes to 0. And then as x approaches positive infinity, that means as I'm going to the right side, f of x is going to be approaching 0 as well. And I know what you're thinking, man. You're like, we can't leave the behavior around my vertical asymptote out the mix. I won't do that. I wouldn't do that to my vertical asymptote. So let's do that last one there. Asymptote behavior. All right. So let's see here. As x approaches 2, we'll go from the left side first. So from the left, as I'm coming from the left, it's going down to negative infinity. So as it approaches 2 from the left, f of x, why did I put that arrow there? There shouldn't be an arrow there. I did that once before too, man. I'm getting excited about my arrows. So we'll just make this a terrible blob right there. That's a little better. All right. F of x approaches, what do we say? Negative infinity. There we go. Negative infinity. And then as x approaches 2 from the right, what's f of x doing here? Well, as I come from this side to my vertical asymptote, as I come from this side, from the right side, is shooting up. So we're going to positive infinity. Woo! Man, we did bonus math. We were only asking for a couple things here, but we're like, hey, this sounds cool. Hey, this sounds cool, because math is cool. And you guys are cool. And that's about it, man. You guys have a wonderful, fantastic day. I'll see you later.